Right now, as you're listening to this, the sun is blasting Earth with 173,000 terawatts of energy. That's more power in 1 hour than humanity uses in an entire year. Now imagine this. In the next 8 minutes, that number drops to zero. No explosion, no warning, just darkness. Before you say, "That's impossible," you're right. The sun cannot simply switch off like a light bulb. It's a 4.6 billion-year-old nuclear fusion reactor converting about 600 million tons of hydrogen into helium every second. Physics doesn't allow it to just stop instantly. But here's the thought experiment scientists use to test our understanding of gravity, climate, and life itself. What if, somehow, the sun suddenly went dark? First, nothing happens. For 8 minutes and 20 seconds, life on Earth continues completely unaware. That's how long sunlight takes to travel the 150 million kilometers between the sun and Earth. Even more mind-bending, gravity also travels at the speed of light. According to Einstein's general relativity, we wouldn't feel any change in the sun's gravitational pull until that same 8-minute 20-second mark. So for 8 quiet minutes, birds fly, traffic moves, markets trade, and you scroll your phone, unaware that the sun has already gone dark. Then it hits. The sky goes black. Not twilight, not sunset, black. In the middle of the day, stars suddenly appear. Planets shine brightly. The Milky Way becomes visible from everywhere on Earth. And at that exact same moment, Earth stops orbiting the sun. Without the sun's gravity reaching us, our planet would continue moving in a straight line through space at about 30 kilometers per second. We wouldn't spiral outward. We wouldn't be pulled away. We would simply drift into deep space. Now here's where most people get it wrong. You might think we would freeze instantly. We wouldn't. Earth has thermal inertia. The oceans, land, and atmosphere store heat. But the cooling would be relentless. Within the first hour, global temperatures would barely change. Within 24 hours, the average surface temperature would drop a few degrees. But after 1 week, Earth's average temperature would plunge to around minus 17 degrees Celsius, about 0 degrees Fahrenheit. Let that sink in. In just 7 days, the entire planet would be below freezing on average. Photosynthesis would stop immediately. Plants rely on sunlight to convert carbon dioxide and water into glucose. No light means no energy production. Within days, plants begin to die. Within weeks, most plant life collapses. And when plants collapse, food chains collapse. Herbivores starve first, then carnivores, then omnivores, including us. Now here's a controversial twist. Humanity wouldn't go extinct immediately. In fact, small pockets of humans could survive for years, maybe longer. How? Because we are no longer fully dependent on sunlight. We have nuclear power. We have geothermal energy. The Earth's core is about 5,400 degrees Celsius, and geothermal heat constantly flows outward. Even without the sun, geothermal vents at the bottom of the ocean would continue pumping heat and supporting microbial life, just as they do today, completely independent of sunlight. In fact, scientists believe life on Earth may have started around hydrothermal vents, not in sunlit shallow waters. So while surface ecosystems collapse, deep-sea life near these vents could survive for millions of years. Let's go back to the surface. After 1 month without sunlight, average global temperatures would drop below minus 40 degrees Celsius. Oceans would begin freezing from the top down. Sea ice would expand rapidly toward the equator. But oceans would not freeze solid overnight. Water is an incredible insulator. Ice forms on the surface, creating a barrier that slows further heat loss. Models suggest that while the surface oceans would freeze within months to years, the deepest parts could remain liquid for thousands, or even millions, of years due to geothermal heat from below. After 1 year, Earth's average surface temperature would fall to around minus 73 degrees Celsius, about minus 100 degrees Fahrenheit. At that point, the atmosphere itself begins to change dramatically. Carbon dioxide would start freezing out of the air as dry ice. Over long timescales, even nitrogen, the main component of our atmosphere, could begin to liquefy and freeze as temperatures approach minus 196 degrees Celsius. Eventually, after millions of years drifting in interstellar space, Earth's surface temperature would stabilize around minus 240 degrees Celsius, only about 30 degrees above absolute zero. The only remaining heat would come from radioactive decay inside the planet and residual geothermal energy. The surface would be a frozen, airless wasteland. But here's the part that should make you pause. Life might still exist. Microbial ecosystems deep underground, warmed by geothermal heat, could continue surviving. Scientists have already discovered microbes living kilometers beneath Earth's surface, feeding on chemical reactions in rocks, completely cut off from sunlight. In other words, even if the sun went dark, Earth might not truly be dead, just transformed. Now let's confront another misconception. Would we instantly suffocate? Not immediately. The atmosphere wouldn't disappear overnight. The loss of sunlight doesn't blow the air away. However, as temperatures drop over years and decades, gases would gradually condense and freeze. Breathing would become impossible long before that due to extreme cold and ecosystem collapse. But it wouldn't be an instant vacuum scenario. And what about technology? Solar power would vanish immediately, cutting off a major energy source that now accounts for roughly 6% of global electricity generation as of the mid-2020s. Agriculture would fail. Supply chains would collapse. Within weeks, global civilization would face unprecedented crisis. But nuclear submarines could still operate. Underground bunkers powered by reactors could function. Countries with advanced infrastructure might attempt controlled indoor agriculture using artificial lighting powered by nuclear or geothermal energy. The real bottleneck wouldn't just be heat. It would be food. Modern civilization feeds over 8 billion people through sunlight-driven agriculture. Without the sun, scaling artificial food production to sustain billions would be nearly impossible. Most of humanity would likely perish within months to a few years, not from cold directly, but from starvation and societal breakdown. So here's the uncomfortable truth. The sun is not just a bright object in the sky. It is the foundation of nearly every energy system we depend on: food, climate, weather, ecosystems, even fossil fuels, which are ancient sunlight stored in chemical form. Every meal you've ever eaten is transformed sunlight. Every breath of oxygen you take exists because of photosynthesis powered by the sun. We live on a planet that survives entirely on a star 150 million kilometers away, and we barely think about it. And yet, here's the final twist. The sun will eventually go dark, but not suddenly. In about 5 billion years, it will exhaust its hydrogen fuel, expand into a red giant, and likely engulf Mercury and Venus. Earth may be incinerated or stripped of its atmosphere long before the sun finally becomes a white dwarf. So the real existential threat isn't sudden darkness. It's cosmic time. But here's what's beautiful. For billions of years so far, the sun has been remarkably stable. Its energy output varies by only about 0.1% over its 11-year solar cycle. That stability is one reason complex life evolved at all. We are living in a narrow window of cosmic luck. A stable star, a protective magnetic field, a planet at just the right distance. Remove one variable, and everything changes. So the next time you feel sunlight on your skin, understand what you're experiencing. Energy that began as nuclear fusion in the sun's core, traveled for thousands of years to reach the surface, then crossed space for 8 minutes to reach you. If the sun went dark, Earth wouldn't explode. It wouldn't shatter. It would simply freeze, drift, and fade. And most of us wouldn't even know it happened until 8 minutes later. If you found this perspective mind-expanding, follow for more science that makes you see reality differently. Now tell me, if humanity had 8 minutes of warning before the sun went dark, what would you do in those final moments of light?